All right, welcome to this inaugural screencast for the Data Matson YouTube channel. Today I'm going to talk about Ansible Tower, how to integrate that with the Ansible Nimble Storage role, and how to kind of weave that all together to get RBAC functionality baked into the HPE Nimble Storage array. And today we don't natively have that type of functionality with Nimble. We do have customers that leverage our REST APIs directly to build that type of workflows within their infrastructure. But with Ansible Tower, this is just something that we can cobble together without any programming skills, just leveraging Ansible Tower, the Nimble Storage Ansible role, and obviously a Nimble Storage array. We do actually support HPE Cloud Volumes with these workflows as well, as the Ansible role supports HPE Cloud Volumes. But we're going to show it with an array today. And so before I kind of kick this off, I just want to kind of explain what I've done here to kind of make this demo as seamless as possible. So within Ansible Tower, I have an organization, a Nimble Storage organization. Within that organization, there's a engineering team, which I have created a user myself to basically run a predefined template that's been defined by a storage administrator in conjunction with the Ansible Tower administrator, and I will simply supply variables through a few prompts to provision storage to one of my servers that I have running within my engineering organization. So let me kick this off here. What I'm showing here within this little target machine here, the host name is target, is that I'm doing a disk free on this particular mount point. And what we can see here that I don't have anything there, no such file or directory. And what's going to happen here at the end is that we're going to end up with a volume on that mount point. And do take note that I'm logged in here on this particular machine as a regular user, right? And now I'm going to flip over to the Ansible Tower UI. I'm going to log in with my user. And within Ansible Tower, I have set up a template that users can execute within this particular team, right? Which is called provision Nimble volume. And if we just glance over here a little bit here, so all these fields that you can see here, they're all read-only. Like which playbook to run, which inventory that you can run this particular playbook against, and which within a certain project this resource exists. And the cool thing here is once we actually go down to, we got the inventory engineering host here. I only have one host in here. For some reason, don't click that right now, but never mind. We're going to run this particular template. I'm going to limit it to my target host, which is named target in my inventory. And here is kind of where it gets interesting, is that I can specify a volume name and where to mount it. I want to mount it on the mount point that I showed on my virtual machine where I want that storage provisioned. And a cool thing here is that you can set your own constraints on these survey prompts that the actual end user is inputting data into. Like I can set a constraint on my Nimble volume name so it conforms to the characters that we support on the array, and I can also set a range between how large I want this particular team to create volumes, right? So I got like 1 gig to 100 gig, and I'm going to create a 33 gig volume here. Just going to click next, and what you see here is basically just extra variables that are being passed into the provisioning playbook that I've set up in this project. And that playbook is just a wrapper around the provisioning workflow in the Ansible Nimble role. And what you can see here is we have the Nimble Array UI, and I just want to showcase here that we have a folder set up here on a Nimble Storage Array. And the neat thing here is that we can leverage other capabilities of the Nimble Storage Array here that is suitable for multi-tenancy, such as setting a capacity constraint on the folder, setting a IOPS and throughput limit on the folder. So I'm just going to bounce back here to Ansible Tower, and launch this playbook. Once it kicks off here, it will take a minute or so, I guess. And as with all these things, when provisioning resources across a stack like this, it's 90% error checking, which is the normal case here. And once everything's been verified, creating the volume, creating all the access control records, and formatting that tiny volume doesn't really take that long time. You also do the iSCSI discovery and so forth. And it also sets up the mount point in /etc fs tab and all that. All right, it's done. So we can see that the job ran successfully. It's all green here. And now we can go back to the virtual machine and actually run that same command again. And we see that we have a multipath device mapped to the host and have a XFS formatted file system on there. And it's basically ready to use for my application on that particular host. And this is without any administrative privileges on the array, on the host itself, or anything like that. I'm obviously logged into the Nimble Storage Array here for demo purposes to show you what's actually being created on the array, but the end user does not have access to this particular part of the UI. The point of entry for the end user would be the Ansible Tower UI or the Ansible Tower REST API, for that matter, if external automation needs to be weaved in here. So, and that pretty much concludes this demo. This is just a very brief introduction to how powerful Ansible Tower is and the RBAC functionality that is actually being provided in there. This would scale to multiple organizations, multiple arrays, and multiple teams within those organizations, and you get very, very granular control of who can do what, right? And most of the basic storage resource operations are supported through the Ansible role that we have for Nimble Storage and HPE Cloud Volumes. So take a further look on the role on Ansible Galaxy. Provided some links here for you. And please stay tuned for more content on the Data Matson YouTube channel in the future.